this is Anthony Precella working some financial math problems with my favorite Math 1324 class. And we're going to do one that deals with future values of an annuity. So this is problem 6 in your homework. A man deposits $14,000 at the beginning of each year for 10 years in an account paying 4% compounded annually. He then puts the total amount on deposit in another account paying 9% compounded semi-annually for another 7 years. I sort of wish it's implied, I wish it actually said he stops the payments at that point. Okay? So we have a series of equal periodic payments, $14,000 a year. It's being put into this account for 10 years. He then stops those payments and takes the lump sum and puts it into another account and just lets it sit there. So find the final amount on deposit after the 17-year period. We might have done a problem like this the last class meeting, but I don't believe it dealt with, I think it was an ordinary annuity, not a annuity due. The fact, and it might be hard to see that, but the fact that it says this is at the beginning of each year, that implies this is going to be an annuity due. So on the timeline, it's a 17-year timeline. This first timeline, first part of it, is the 10-year period where he's depositing $14,000 at the beginning of each year. That $14,000, that's the payment. It's the periodic deposit, the periodic payment. So this person's depositing $14,000 at the beginning of each year for 10 years in an account that pays 4% compounded compounded annually. He then puts the entire amount in another account which pays, he then puts the entire amount on deposit in another account that pays 9% compounded semi-annually for another 7 years. Find the total amount on deposit after the entire 7-year period. Can y'all read that problem, or do I need to zoom in more? Y'all read what's going on? A man deposits $14,000 at the beginning of each year for 10 years into an account that pays 4% compounded annually. He then puts the entire amount on deposit in another account paying 9% compounded semi-annually for another 7 years. Find the final amount on deposit after the entire 17-year period. Okay? Oh, my blue ink isn't looking very good. Maybe I'll change the blues. But starting off, we'll do this first part here. This is a future value of an annuity due. How do I know it's an annuity? Well, there's a series of equal periodic payments. Equal periodic payments mean an annuity. We're assuming this account starts off with how much money? But, well, right before he puts in the first $14,000, it's zero. He deposits $14,000 from there, okay? But when he opened the account, it was at $0. Our annuity formulas always assume that the initial value is 0, okay? So we're looking at future value of an ordinary annuity. S equals R times 1 plus I to the n plus 1 minus 1 all over I minus R. Okay. Now let's calculate or identify the variables. What we're trying to find is this future value right there. So S is our unknown. R, the periodic payment, is the $14,000. Now to get I, the interest rate per period, we normally divide. To get I, 4% compounded annually. The little phrase I say over and over is to get I, you normally divide. To get N, you normally multiply. 4%, but there's only one annual period per year. So this is the one time that I and the stated rate are the same thing. If it's compounded annually, then I and N are I is the same as the stated rate. N, how many annual periods are there in 10 years? 10. Okay, so N is 10. So if it's annual compounding, then I and N, okay, then I and N are just the stated rate and the number of years. Okay, so plugging in S equals 14,000. When I punch this stuff in my calculator, I try to avoid using parentheses as much as possible. And I do as much in my head as possible. Okay? All of you know how to calculate 10 plus 1. Don't let the calculator do that, or else you're introducing a whole new set of parentheses. Just like 1 plus I. All of y'all know $1 plus 4 cents is $1.04. I do the 1 plus I in my head. Let me move this up a little bit. So that's a 1.04. Now I'm about to do the N plus 1 in my head. 10 plus 1, all of y'all know that's 11. Then a minus 1 all over I. And then subtract R. So to punch this into my calculator, and I can't really show it that well, that's the downside to using this document camera. The glare especially looks bad up there, but usually when you watch it, the video, it looks pretty good. But the glare shows worse up there on that projector. Let me see, should I? Let me just start punching in. I'm going to punch in the bracket number 1.04. Raise it up a little. Okay. 1.04 raised to the 11th power minus 1. And the way I normally punch this in is I always punch in the bracket number first. I punch in the top, hit enter, and then divide by the bottom. So divide by 0.04, hit enter. Now times 14,000 and then subtract 14,000. This is the future value of an annuity due formula. So at the end of the 10 years, this person's deposits would have grown to $174,800 and $808. Ooh. And 92 cents. Oh. Oh, should have told me. $174,808.92. That's the bad thing about using the document camera. The calculator doesn't show too great with that glare. So any questions up to this point? Y'all see how I calculated I and N? Here there's not much to it. It's annual compounding. So the interest rate per period is just that stated rate. The number of periods is just the number of years. This is a classic savings problem where you save for a while and then you just let it sit for a while. Okay? So I'm now going to start looking at the blue part of the timeline. Well, let me go ahead and make a note. The $174,808.92. Was there any questions or problems punching that in? Some of you have your calculator out there. If you punch it in, did you get the same thing? The way I like to punch it in is the top part first in the bracket, punch in the numerator, hit equals or enter, whatever gets you an answer. Then divide by the bottom, hit equals or enter, whatever gets you an answer. Then times R and subtract R. Okay. I try to avoid entering parentheses as much as possible. It's the old programmer in me watching those parentheses. If you start trying to have it do the n plus 1, then you better be putting 10 plus 1 in parentheses. Oh, okay. But now on to this, the second part. So now at this point, this person has quit making the $14,000 payments a year. He's just leaving the money sitting there in his account for 7 years. Or he's put it into this new account. He's now paying 9% semi-annual, compounded semi-annually, for 7 years. There's no more periodic payments. This part here is no longer an annuity. Right? The annuity was this part. So what do we have here? Well, we have one lump sum that just sits in the account for 7 years. Which finance formula could we use for that if it's not an annuity? And it's not an annuity. Well, it's 9% compounded semi-annually. We're going to use the periodic compound amount formula. The periodic compound amount formula assumes just one deposit. Put the money in there and leave it with compound interest. And that's what we have here. So what is that periodic compound amount formula? That's the formula that was on your last test. A equals P times 1 plus I to the N. Now, on this part of the timeline, the blue timeline that's hard to see up there, but it'll show fine on the video. Right here, P stands for present value. So the present value is that former future value, $174,808.92. Capital A is standing for the future value. And that's what we're trying to find here. So P is the $174,808.92. A, that future values are unknown. Now on this one, you've got to calculate I and N. I is not just 9%. N is not just 7. Okay? It's when it's annual compounding that the I and N are just those stated rates. Okay? For semi-annual, we got to calculate that. 9% semi-annual. Well, that 9% is an annual rate. So we're going to divide it up for over I've said it. How many semi-annual periods are there in a year? 2. So 0.09 divided by 2 would be 0.045. 9% compounded semi-annual is like 4.5% the first 6 months, then 4.5% the last 6 months. What about N? How many semi-annual periods are there in 7 years? What two numbers do I multiply to figure that out? 2 times 7. There are 2 semi-annual periods per year, 7 years. So altogether there are 14 6-month periods. Semi-annual is 6 months. So plugging in now, P is $174,808.92 times 1 plus I. Again, my desire to avoid parentheses, I'm just going to say times and do the 1 plus I in my head. 1 plus 0.045 would just be 1.045 to the n power, to the 14th power. Let me lift this up. Close it in the pi. And that's what I'm going to punch into my calculator. Okay. So let me clear this out. Let me see. $174,808.92 times 1.045 raised to the 14th power. This person has a nice little amount. Y'all see that? $323,736 and what would y'all call that? 49 cents? $323,736 and 49 cents. That's the amount of money on the account. Okay? Now, if you were curious, how much interest did he earn altogether? You could calculate that. The question doesn't ask, but this person deposited $14,000 a year for 10 years. So how much money did he actually put in there? 14,000 for 10 years, would that be 140,000? So if we just subtract 140,000 from $323,736.49, you can see, oh, he earned a pretty good amount of interest. Okay. Any questions on that? This was one that involved an annuity due, and again, it's very, very rare. Okay? The fact that it specifically says beginning of the year, and or if it had said annuity due, then okay, but here it specifically says beginning. If it doesn't say the word beginning or the word annuity due, you assume it's an ordinary annuity. Okay? Any questions on that? Okay. Oh, let's take a break while I get ready to do another problem. These are I'm working some of the messy problems. Okay? That's what I'm doing today. Oh, thanks for watching.